All right, another installment of notes by me, Mrs. Gartner. So now we're talking about Chapter 5, Section 3, which is talking about concurrency of perpendicular bisectors. Okay? Concurrent just means to intersect at a point, at the same point. Okay? The perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant or equal distance from the vertices. So PY, PX, and PZ, the lines in pink, are concurrent at P. Okay, so that means that PA, PC, and PB are all equal in length. Okay, so concurrent means to intersect at the same point. Okay, so I know that you guys got to write that down, and I'll do that again. I was going to have some fun music or something, but yeah, I'm not that clever tonight. All right, so moving on. All right, the point of concurrency of the perpendicular bisectors of a triangle is called the circumcenter of the triangle. Okay, what does that actually mean? It means that if we have a circle, we can construct, by using a compass, a triangle with a point of concurrency. I know that we haven't done anything yet with constructions. We will, though, before the semester ends. I'm trying to find something online that we can do it, but it's not working, so we may have to break out the compasses. And that's going to involve candy because those things are just something to use, I'm telling you. Okay, so now there are different ways to find the circumcenter. Okay, the two examples I have in the notes happen to be right triangles, so I'm going to show you how to do those. But when I get back on Monday, I'm going to show you how to find the circumcenter when you don't have a right triangle. Okay, so when you have a right triangle, it's very simple. All you have to do is find the midpoint of the hypotenuse. Okay, so what side is my hypotenuse? Okay, well, it would be across from our right angle, and that would be PS. So we're going to use P, and we're going to use S. Remember the midpoint formula, x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay, so let's take a look at, so my x1 would be P, would be 0. My x2 would be 4. And then I would have 6 plus 0 over 2. So that would be 4 over 2 and 6 over 2. Okay, we're gonna write those as whole numbers though. Okay, so I would have 2, 3. So right here would be my circumcenter of the triangle. So if I was to draw a line and a line, okay, that would be on the perpendicular bisector. Okay, so like I said, these are right triangles on the examples, but I believe on your worksheet that you're going to see other kinds, but like I said, we're going to go over that Monday because it's a lot more time consuming. We've got to find midpoints and slopes and all sorts of fun stuff. So we'll wait till Monday to do that. All right, so this again is a right triangle. And we need to figure out what the hypotenuse is, okay? Well, it's AC. Okay, so I'm going to find the midpoint. So I've got 2 plus 10 over 2 and 7 plus 3 over 2. Okay, well that's 12 over 2 and 10 over 2, which is 6, 5. Okay, that's going to be my circumcenter. Right there. See, it works out nice with the right triangle, but when you don't have it, we've got to do a lot of other things, like I said. Okay, so we want to find the value of GF given, well, it's supposed to say G is the circumcenter. So let's fix that right away. Whoops. G is supposed to be the circumcenter, obviously. Okay, so what I want you to see here is, this thing is in my way. What I want you to see here is I'm having issues, obviously, if you didn't know, as usual. So I'm looking at this triangle here. Okay? It's a right triangle because I know that that's right, and so this would also be a right angle. All right? GB would be my hypotenuse, FB would be a leg, FG would be a leg. Okay, so they want me to find FG, which is this line right here. Okay, how do I go about finding a missing side length in a right triangle? Anybody know? Starts with a P. It's a theorem. Starts with a P, ends in Pythagorean. Pythagorean theorem. Okay, so what is that exactly again? Well, make sure you write it down. Why does that not look right? Pythagorean, wow, theorem. That does not look right. Is a squared plus b squared equals c squared. C is the hypotenuse all the time. Hypotenuse. Oh my gosh, my spelling's horrific. Okay, so if I'm looking on there, I have GF, GB, and FB. Okay, I don't know GF. I'll just let that be a squared. B, so these are my two legs. Okay, my b squared would be FB. And then my hypotenuse, which is across from the right angle, is 20 squared. Okay, so we're just going to work this out. And 16 squared I'm giving you guys a minute to actually do this. So 256 equals 400. Okay? So I'm going to minus 256. And that is 144. Okay, am I done? No. I want A all by itself. Okay? Remember my A is GF, which is what I'm looking for. So I need to square root both sides. Okay, a square root and a square cancel, and I'm left with 12. So GF is 12. Okay, I'm sorry if that was confusing, but we're just using the Pythagorean theorem, which you should have seen 1,000 times now in your math careers. Okay? All right, again, we are going to use the Pythagorean theorem to find our missing length. Okay, so we need to determine what sides match up. Okay, I'm going to leave my A as I don't know. That would be my CZ, the line I'm looking for. Okay, my other leg would be 9, which would be CD, and my hypotenuse is DZ. Okay, so let's just fill in. I don't know what that is. I'm looking for that. CD is 9. DZ is 15. Give you a second to do okay, so 9 squared is 81. 15 squared is 225. So again, I end up with 144. Let's switch colors. Take the square root. Okay, don't forget to take the square root. That's the big point. Okay, it's what a lot of kids forget to do is take the square root. So don't forget to do that. Okay. What is next? The sound recorder is just in my way all the time. All right. Okay, theorem 5.7. The bisectors of the angles of a triangle are concurrent at a point equidistant from the sides of the triangle. So AP, BP, and CP are concurrent at P. Okay, so PX equals PY equals PZ, which we've really already had before. Okay, the incenter of the triangle is the point of concurrency of the angle bisectors of a triangle. Okay, so the incenter. So don't get in center and point of and circumcenter mixed up. When we're finding the circumcenter, we are using the Pythagorean theorem. Okay? When we are finding the incenter, we are not using the Pythagorean theorem. And you're going to see why in just a minute. All right, so they want us to find the incenter of this. So think about it for just a minute. Okay, so GE, first of all, here's what I know. I know from my theorem before that GE, GF, and GD, okay, are all equal. That's what my theorem before says. So if I want to find the length of GD, I got to solve for x and then plug it back in, and they're all going to be the same. Okay, so since they equal, then we're going to set them equal to each other. Okay, so minus x okay, so if I subtract 7, okay, why doesn't that make any sense? Oh, okay, well, why? Because on your notes, it's a minus 7. So I'm going to fix that. I'm telling you, one day I'm not going to be a hot mess, but it's not today. Okay, on your notes, this is correct. Because I was like, when I did the notes, I swear it was right. So let's try this again. 2x minus 7 equals x plus 4. You guys ever wonder if I'm absolutely insane? Because I'm starting to almost get the giggles because I've screwed up so many times. Oh my gosh. It is insane. And then some of you are like, who cares? Lady, stop talking. So x is 11. Okay, I can plug that in for either GE or GF, but let's look if I do it for both, what I get. So GE, I have 2 times 11 minus 7. GF would be 11 plus 4. That would be 15. That would be 15. Since all three are the same, my GD would also be 15. Okay? Those are all congruent to each other, or equal. I'm thinking one of these days, everything I do is going to be correct. Okay? That's my goal for the year. Okay, so last slide. Hope to God you stayed with me and you aren't, yeah, I haven't totally lost you. If I have, well, I'll be back on Monday and you guys can ask me questions. Because I'm sure I have lost it. Okay, so I know that QN, QM, and QO are all the same. Okay, so again, we're going to start by setting them equal to each other. Okay, that's an equal. Subtract 36. divide by 3. Okay, so I'll plug that back in. So that would be my QN. I'm just going to check and make sure that it does equal. Okay, so 25 plus 36 would be 61, and that would be 61. So QO better be 61. Okay, so sorry for the issues. I hope to God you were able to follow along. I know it's boring when I'm not there, but at least we can still learn a little something. Um, so I want you guys to have a good weekend, and when I get back on Monday, if you have any questions about anything, okay, we'll take some time to go over that, and so don't worry about that. It's really not going to be a big deal.